In 2024, there will be a stellar explosion visible from everywhere. In the constellation Corona Borealis, there's a very special star known as T Coronae Borealis. This star is actually a binary system containing two very different stars. But what makes this binary star so special? A group of scientists from Louisiana State University recently published a study on this star in the Journal for the History of Astronomy. In that article, they explained that this star could be about to experience a colossal explosion known as a nova in 2024. But what exactly is a nova, and how do we know precisely when it will happen? Stay with us to find out. T Coronae Borealis, TCRB, is a 10th magnitude binary star, meaning it's not visible to the human eye and barely visible to amateur telescopes. TCRB is a binary star, meaning it's not a single star but rather a star system consisting of two different stars. Most stars in our galaxy are of this type. There are theories that suggest the Sun may have had a companion billions of years ago, with both orbiting a common center of mass. Today, this theory remains open in the scientific community, with many astronomers considering the possibility of the Sun having had a companion in the past very likely. Binary stars are intriguing in scientific research because each star in the system can influence the other differently. The stars that make up a double star system are usually called components, and each component has different characteristics. The binary system TCRB comprises a red giant star and a white dwarf star. The system's two components orbit around a common center of mass every 228 days. The orbit is nearly circular and tilted at an angle of 67 degrees. The two stars are known to be extremely close, separated by only 0.54 astronomical units. To give you an idea of how close they are, this distance is less than the distance from Venus to the Sun. In other words, the two stars are so close that the gravitational effects of one influence the other. The biggest star in the system is a red giant in its last stage of life before becoming a white dwarf. On the other hand, the hottest component of the system is a white dwarf surrounded by an accretion disk. This accretion disk is the factor that produces novae, but how exactly are they produced? A nova is a transient astronomical event that causes the sudden appearance of a bright, apparently new star. Hence its name, nova, which in Latin is written nueva and means new. This appearance of a new star is temporary and can last for weeks or months. But as we mentioned, it's not the appearance of a new star, but rather a phenomenon that unleashes a brightness which, seen from Earth, gives the impression that a new star appeared. But how does a nova occur? A nova forms from two main sequence stars in a binary system. Normally, the stars in a binary system are very similar. However, most of the time, one of the two stars will have a greater mass than the other, so the star that has more mass will consume its fuel faster and reach its final stage of life sooner. When one of the two stars evolves into a red giant, it begins to die, ejecting its outer layers and scattering all the materials it formed during its lifetime into a planetary nebula. When the star has ejected all its outer layers, in the end, only its core will remain, which we know as a white dwarf. This type of star, although they seem small and cold, still retains a large amount of mass. The mass of a white dwarf is comparable to that of the Sun, while its volume is comparable to that of Earth. However, this new white dwarf is still gravitationally anchored to its sister, which has not yet reached its last stage of life, and both continue to orbit around a common center of mass. When the second star reaches its last stage of life, it begins a process similar to the first becoming a red giant, and then gradually beginning to free itself from its outermost layers composed mainly of hydrogen. However, at this stage, something extraordinary happens. The outer layers released by the second star begin to be absorbed by its companion, the white dwarf. As a result, the white dwarf constantly captures matter from its companion's outer atmosphere and begins to form a hydrogen accretion disk around it. Since the white dwarf is made up of degenerate matter, hydrogen does not inflate, but its temperature increases significantly, becoming ionized hydrogen. Hydrogen fusion can occur stably on the surface of the white dwarf, resulting in a supersmooth X-ray source. Still, hydrogen combustion is usually thermally unstable and quickly converts into other heavier chemical elements. This creation of elements from hydrogen causes an exothermic reaction that releases enormous energy. This ejects the remaining gases from the white dwarf's surface and produces a bright light in an explosion. This burst is what we call nova, a drastic increase in a star's luminosity. This brightness increase can be remarkably rapid or gradual, so once the burst of light occurs little by little, the brightness decreases until the star returns to its average brightness. The time it takes for a nova to decay by about 2 or 3 magnitudes from maximum optical brightness varies depending on the size of the star. Fast novae will normally take less than 25 days to decay by 2 magnitudes, while slow novae will take more than 80 days. What type of nova is T Coronae Borealis, TCRB? TCRB is classified as a recurrent nova because it has had different novae with a certain periodicity since this star began to be observed. How do we know it will explode in 2024? As mentioned above, TCRB has had explosions in the past that are currently recorded by the American Association of Variable Star Observers, or AAVSO. The first occurred on May 12, 1866, and the second on February 9, 1946. Both events were TCRB explosions. They reached a magnitude of 2 and were bright enough to be observed with the naked eye. The astronomers discovered, however, that before the star's luminosity increases, it decreases its brightness a bit. In his research, scientist Justin D. Linford of the Department of Physics and Astronomy of West Virginia University analyzed the star's state of activity between 2015 and 2016 and realized that during this period, the star became much brighter than usual and expelled a more significant amount of X-rays. The scientists collected information from different radio telescopes and telescopes, obtaining data with which they could create a model of the star's behavior. They concluded that the star's behavior today is very similar to what was observed in the 1940s when the last explosion occurred. To corroborate this, they compared the data obtained with the data from 1938, and the similarity was evident. The way the star behaved during 2015 and 2016 is very similar to how it behaved in 1938, 8 years before the 1946 nova occurred. According to current records, this corroborates existing information about past TCRB explosions. In 1945, a year before the 1946 explosion, astronomers observed that the total brightness of this star decreased by 2 orders of magnitude, from +10 to +12. Remember that in astronomy, the greater the magnitude, the dimmer the object appears. Thus, the higher the magnitude, the more difficult it is to observe. The maximum magnitude visible to the human eye is approximately 6 or 7. Beyond these numbers, our eyes can no longer perceive anything. So if you try to observe a star with a magnitude of +8, +9, or +10, you simply won't see it. This difficulty in observing the star is also due to the fact that it is very dim and can only be observed with special telescopes or binoculars. Returning to the main point, TCRB seems to have a recurring pattern before an explosion. First, it decreases in brightness for about a year, then returns to its original brightness, then 7 years later, its brightness decreases again for a few months. Finally, a year after the last period of brightness, a nova explosion occurs, and the brightness increases by a factor of +8, becoming visible to the naked eye. Observations from last year, 2023, indicate a decrease in TCRB's brightness, which occurred 7 years after the last period of dimming in 2016. This strongly suggests that TCRB will definitely explode again in 2024, producing a nova visible to the naked eye. So how and where can we observe this event? Although this event won't repeat for another 80 years, there's a margin for it to occur between April and September, giving us a few months of opportunity. When the event occurs, you should look for a star with a magnitude of 2 in the sky. Stars with a magnitude of 2 are not actually very bright. In fact, they are challenging to locate from 1 magnitude upwards. But to know exactly where to look, remember that TCRB is located in the constellation Corona Borealis, just below the crown, to the left of the star Alphecca. On a typical night, you can observe the Corona Borealis constellation as a small semicircle in the middle of the Bootes and Hercules constellations. This is where the TCRB explosion will appear as a new bright star, transitioning from a brightness of +10 to +2. Therefore, it will have a brightness similar to that of the North Star. When it reaches its peak brightness, it should be visible to the naked eye for several days, and then likely fade again for another 80 years. Finally, one thing to remember is that this star is approximately 3,000 light-years away from Earth. In reality, the light from this star left 3,000 years ago, and we won't really know what's happening in this star until the events reach us in the year 5024. So, the nova we'll observe this year might have occurred 3,000 years ago, but its light will only reach us this year.